All right. So guys. Okay, let me get your attention. Let's go back to the squares and see how that worked. We had a single dot for the first square, right? What are the dimensions of this dot? Brian?
1 by 1.
It's 1 by 1. What's 1 times 1?
2.
1. Okay. The dimensions of the second one. It's a 2 by 2. What's 2 by 2?
4.
4. The next one. Guys,
Do you just divide by 2?
a lot of talking. The next one. 3 by 3. Which is 9.
Doing
So you would just divide.
So, what we're doing over here is we're multiplying the height by the base. 2 by 2. The height, 3 by 3. Let's go back here. What is our height? 2. What is our length? 3. But 2 times 3 doesn't give me 3, does it? What's it give me? 6. Am I looking at the entire size of this figure? I'm looking at half of it. What's half of 6?
3.
I'll get it.
How about this one? Brian?
It would be 3 by 4, which is 12.
So, 3 by 4 divided by 2. I get 6. Okay. How about the next one? 4 by 5. Now the trick. Ryan.
So would the equation be n parentheses n plus 1 n parentheses divided by 2?
N parentheses n plus 1 divided by 2?
Yep.
What do you guys think?
Wait.
What do you guys think? Ryan said he thinks the pattern is n times n plus 1, all of that divided by 2.
Yes.
I disagree too.
Okay, let's see, show thumbs. Thumbs up if you agree.
I just
It says at the bottom of the page.
Yeah.
That's different.
Okay. Thumbs down if you disagree.
I disagree.
Brenica, you disagree. Why?
Fine.
Because if you plug it in, then that's saying that, like, if we look at our, wait, hold on. Oh, I see what you're saying now.
That doesn't make
So
sense.
wouldn't n be
Time out.
2 plus 1 is 3.
Time out. Okay, Brenica, I'm going to let you stew on that for a second.
Okay, but because. No, that's just, I wrote it differently.
What's 4 times 3?
Okay. Martha.
It works.
I agree that it applies to these rectangles.
I wish I could hear Martha. Sydney. Okay, go for it.
I agree that it applies with these rectangles, but with all rectangles, I don't.
And it's not with all rectangles, right?
Which is in this sequence.
It's perfect.
What are we looking at? Are we looking at all the dots, or are we just looking at the blue ones?
Just the blue one.
We're just looking at the triangle. This is to make our life a little bit easier so we can see this pattern. Okay? It's just to make our life easier so we can see the pattern. But really, all we're focused on is that. You're right. What's the formula for finding the area of a rectangle? Base times height, length times width. Correct? What's the area for finding a triangle?
Wait, no, that doesn't work.
Is that what we just found?
Because 25 divided by 2 is not big.
Guys?
Oh.
I've got 5 people talking. I think, Haley, I can't take everyone's questions. Okay, Raul first.
Never mind, I was looking at the wrong square.
Okay, Harry.
Is n plus 1 like, how many are you going?
Width, you're going out every time?
So, n, I think we all recognize is the height of this thing, correct? So we say n, or 2, is the height. N plus 1 is just saying, if I put those green dots back in, what is the length of the base? It's 5 for here, or it's 4 for here, or it's 3 for here. It's just looking at the dimensions of this figure. It's just looking at the dimensions of the figure. Question? Okay, Haley.
So when you take n and you do it plus 1, you just add okay.
Is that what we did here? What do you have to add to 3 to get to 4?
1.
What do you have to add to 4 to get to 5?
1.
What do you have to add to 2 to get to 3? So what what Ryan noticed is that there's a pattern here. Can someone let Mr. Goodney in? There's a pattern here. And what they saw is that if we just want to talk about some random term far on down the line, some nth term, if I want to find the area of that triangle, I just need to look at the base and add 1 to it. Divide by 2. And I've got a way to find the area for this figure. Only with whole numbers though.
Would the triangular number be Sn?
Would the triangular number be S? What do you mean by that?
Well, it says on number 9, what is the 100th triangular number?
Well, so let's first write our equation down. Yes?
I was just gonna steal if I could get stuff from 8th grade math. But I kinda wanna stick around for this.
Okay.
I love triangular numbers.
Alright, so, John, you're taking it to where I want to go. We don't want to start drawing hundreds and hundreds of dots, right? That sucks. So let's see if we can take this. We think this is our equation, S of n equals n times n plus 1 over 2.
And would n be 100?
Okay, so if we want to find out what the 100th term of this sequence is, we plug in 100. So 100 times 100 plus 1 divided by 2. Okay, what do we get? 50/50
Yeah, if I do it right.
divided by 2.
No, I just divided by 2 already.
Oh, thank you.
Yeah.
Yeah, sorry. All right.
1,100 if you just do it.
So 5,050 units squared is what we get for the area of a triangle that has a base of 100 and follows this pattern up, so we get 101.
Makes sense now.
Okay, good. We like that. All right. So let me see really quickly. Who understands the steps that we just took? Who understands those steps that we just took?
I got it.
Woohoo!
Really understand.
For one.
Sometimes when you
Oh, shit.
Okay, who's still totally confused about what we just did? Who is still totally confused about what we just did? Alright. Now, let's go back to Socrates and Plato with the wonderful hair. Which, by the way, apparently Mr. Ryden has much more fluid hair than I do, I found out. I'm really disappointed.
Who doesn't?
You're telling me Ryden looks like the dude on the left up there?
More than you do.
Oh man, I'm gonna have to get a beer.
Yeah, I was gonna say, he at least has a beard.
At least I don't look like Socrates, right?
Socrates, he's a good guy.
Mr. Blackman looks like so great.
Have you guys seen Bill and Ted?
He's on your nose.
Oh, absolutely.
You scared me for a second. Like, oh god. Alright, anyway. So back to this. Back to this, guys. So, if we were to plug in, say, 50 for this sequence, would we get an answer that makes sense to Socrates?
Yes. No.
Okay, we would.
Anyway.
We can definitely look at the nth term, the 50th term, we can plug it in, we can find something that makes sense. Alright?
Good.
Nick.
So what's the answer for 10, 11, and 7?
Okay. How about 0? Can we get an answer for it if we plug in the 0th term?
No.
Okay. Not something that really makes sense. Can we plug it into our fancy little calculators and get a number out? Yeah.
Maybe that's one.
Yeah,
Is that what you want us to?
Just half.
Should it be half? Shouldn't be half.
Oh.
Multiply by, yeah. Alright. But then we start getting to other ones. -1. Does -1 make sense in this context?
No.
This doesn't make sense.
It's definitely getting weird. Pi?
So the domain is the same as last.
Okay. So if we want to look at the domain for this one,
The domain is an element, or, well, n is an element of all real integers.
What number are we on?
hold on.
I would just like doing the admin stuff.
So n is an element of all positive
Positive
integers.
integers except for 0. Above 0.
I don't like that E thing. It's
Positive integers. It's all positive integers. Okay?
Above 0.
Now, this is all great and fine and dandy if we've got triangles that are units 1, 2, 3, 4, and so on. But we don't. We've got them that are 1.5, 1.7 units. So how do we address that? Well, if we want to come up with a triangular area based on some value for x times x plus 1 over 2.
May I have your attention, please? I need the following students to please report to 181B next period. I will need Damian Gallegos, Vanessa Soto, Adrian Torres, Madison Stolley, Amanda Perez, Diane Macias, and Brianna Fernandez. Please report to 181B for Explore Makeup Testing. Thank you.
You in a rush this morning?
Sam, I just realized we got 2 minutes left and I haven't given you yours to get yet. So, do we have any homework? Yeah, hold on 1 second. Okay, so really quickly, we've done this pattern twice now. Before you guys leave, I want you guys to complete this exit ticket. Or scratch that. Scratch that. We're not going to do that. Listen up.
We wouldn't have even gotten it by the time.
I know. You guys wait here on time. The bell's going to ring and I'm still going to be passing these things out.
Hey!
Because Haley's not paying attention. Okay. So, this is your homework. I'll be looking this over tomorrow.
What's the packet or the?
The handout, the exit ticket. So get this to me by tomorrow. This is your homework. My class for theater, we're in the auditorium today, so head on down there if you're there.
Wait, you go around.
What? You're kidding.
Whatever.
What?
Okay.
I heard you couldn't play it though. Oh God.
Really?
Well, we haven't done much, so wait till the show starts. Other thing, Ryan, it's always terrible luck to